Right, we're looking at quadratic functions of this form here. Okay. Now, it's a parabola. Okay, it's going to look something like this. It's a negative one, it'll look something like this. Okay. Right, so if we start off with x squared, we put a number in front of it, such as a 2 or a half. Remember, that's vertical stretching or shrinking. If we move it left and right, it's this, x minus h. Okay, this is the left and right movement, the horizontal translation. And think about it, if that was, say, x minus 3 all squared, I'd be moving it 3 to the right. Okay. If I have this here, this is the vertical translation. Okay, again, if I had plus 3 at the end there, plus k plus 3, I'd move it up 3. So, the vertex is where the graph turns. Okay, right there. This is the vertex. It could be a minimum, it could be a maximum, depending on whether it's a positive x squared or a negative x squared. Right, so that's the vertex. Now, the graph also has a point of axis of symmetry. It's a line, it's a line axis of symmetry. And that is the x coordinate of the vertex. Okay, do it here as well. The x coordinate of the vertex. Because think about it, it's kind of reflected over that axis of symmetry. Okay, so the vertex, you will have a point, well, we call it HK. Where is it? HK. Let's call it HK. The x and y coordinate. So the axis of symmetry will be at x equals h. And the minimum is the k value. Okay, but the vertex is HK. So let's have a look at an example. Okay, so we've got y equals, or f of x equals 2x plus 3 squared minus 2. So this has been moved 3 to the left and 2 down. So its vertex is negative 3, negative 2. Now can you see this is the opposite of this, and it is this. It's right actually there in the question when it's this form. So look over here, the vertex of this is going to be positive 1, positive 3. Again here, positive 1, positive 3. So let's have a look at some more information. If I know the vertex is negative 3, negative 2, because I've taken it straight from the question, then the axis of symmetry is the x coordinate, negative 3. So x equals negative 3 is the axis of symmetry. And the minimum is the y coordinate, okay, negative 2. Let's have a look at this one. Again, the vertex was 1, 3. The axis of symmetry is x equals 1. Again, I use the x coordinate. And the minimum is 3, right there. Okay, this is the same thing, but this has a maximum because it's a negative 2 in front of everything, right here. Okay, so you're going to have the same vertex, the same axis of symmetry, the same maximum, but it's just an upside down parabola. Okay, and if we look at some quick connecting the concepts, here we go. So this one, let's have a look. This is a positive one. This is a negative one. But here's the vertex, so the minimum is at k. The minimum is k. The axis of symmetry is the h value. Again, the axis of symmetry is the h, the x coordinate, and the maximum this time is the k, okay, when it's a negative version of the x squared, okay? Right, let's look at some more. Okay, so again, look at this one. Just an example here. Can you see the vertex is going to be positive 1/4, negative 2. There it is. This one is negative 5, positive 7. There it is. Okay. So again, if I had to draw it, here's a minimum because it's a positive, right, at the vertex 1/4, negative 2. This is going to be a maximum because it's got a negative in front of this x squared. So again, the vertex is still what I found, but it looks like this. Okay, so the axis of symmetry, the x coordinate, x equals 1/4, x equals negative 5. The maximum, this doesn't have a maximum, it's got a minimum, but it is the negative 2. Okay, there it is. And this has a maximum, okay, and it occurs at 7. It is 7. There we go. The axis of symmetry is the negative 5. I think I already said that. Doesn't have a minimum because it opens this way. Okay.